In this lesson, we are going to find the number of solutions of a quadratic by using the discriminant. So what is a discriminant? Remember that the quadratic equation is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. The discriminant is the expression inside the radical, and that is this expression. So our discriminant is b squared minus 4ac. We want to be able to find the number of solutions of a quadratic equation by just looking at the discriminant. So if our discriminant is a positive value, we have the equation with two solutions. If the discriminant is 0, then the equation has one solution. And if the discriminant is negative, then the equation has no real solutions. So let's begin by looking at a few examples. The first thing we want to do when we're finding the number of solutions with the discriminant is label our points, A, B, and C. Then we'll take our equation, b squared minus 4ac, and we will plug in these values. So if our b is negative 2, we get negative 2 squared minus 4 times a, which is 1, times c, which is 4. So negative 2 squared we know is 4, minus 4 times 1 times 4 is 16. So we get 4 minus 16, which is negative 12. And remember, if we get a negative number, we have the answer of no real solutions. Okay, so if we have no real solutions, that means that our graph is not going to touch the x-axis at all. And remember from previous lessons, we have to decide whether it's going to go up and down by our a value. So since our a value is positive, we know that it's going to go up. And since there's no real solution, we're not going to touch the x-axis at all. So our sketch is going to look like this. Graph is facing up, not touching the x-axis at all. Okay, so for our next example, first things first, label your A, B, and C. The next thing we're going to do is plug that into our equation. B is 5, so we get 5 squared, minus 4 times A, which is negative 3, times C, which is negative 1. So first thing we want to do here, negative 3 times negative 1, positive 3. Negative times negative is positive, right? 4 times 3 is 12. So we have 5 squared, which is 25, minus 12 is going to give us 13. 13 we know is a positive number, so in this equation we have two solutions. Let's take a look at our a value before we sketch. We see that our a value is in fact negative, so we want this graph to be pointing down, but we also know it has two solutions, so it's going to touch the x-axis twice. So if it's pointing down and we're touching the x-axis twice because we have two solutions, our sketch is going to look like this. Okay, next example. We have negative x squared minus 10x minus 25. First thing, A, B, and C. Plug those values in. B squared is negative 10 squared minus 4 times A, which is negative 1, times B, which is, or C, which is negative 25. Okay, let's simplify this. Negative 1 times negative 25 is a positive, so these will give us a positive 25, times 4, still have our minus here. Negative 10 squared will give us a positive 100. That will give us 100 minus 4 times 25 is 100, so our answer is 0. And if our answer is 0, we know from our notes that we get one solution. So once again, before we sketch this graph, we need to take a look at our A value, which we can see is negative. So our graph is going to be pointing down and only touching the x-axis one time. And so our graph is going to look very similar to this. Okay? The next examples say to find the number of x-intercepts. And don't worry, this is exactly what we just did in the last 3 examples. The number of x-intercepts of the graph of y equals ax squared plus bx plus c is the same as the number of real solutions of the equation. So, we're going to begin just like we did before. The only thing that it's not asking us to do this time is to sketch it. They just want the number of x-intercepts. So, first we'll do exactly what we've been doing. Label our a, b, and c values. The next thing we want to take a look at is plugging it into our equation of our discriminant b squared minus 4ac. So b squared is 6. So we have 6 squared minus 4 times a, which is 1, times c, which is 3. So 4 times 1 times 3, that will be 12. Keep our minus in the middle. 6 squared is 36. 36 minus 12 is 24. 24 is a positive number, so we know that if we have a positive, we have 2 real solutions. So the answer is 2 x-intercepts. Next question, I'm going to switch colors. Label your A, B, and C, please. Plug those into the equation b squared, which again is 6 squared, minus 4 times a, which is 1, and times c, which is 10. 4 times 1 is 4. 4 times 10 is 40. So we have a minus still in the middle. 6 squared we know is 36. 36 minus 40 equals negative 4. We have a negative number, and from the notes we know that if we have a negative number, we have no real solutions. So it's asking how many x-intercepts? We have 0. In the next question, it's asking us x squared plus 6x plus 9. We really like the 6x's apparently. Let's label our a, b, and c. Again, we have 6 squared because our b is 6 minus 4. A is still 1. And our c value is 9. 4 times 1 again is 4. Times 9 is 36. So we have 6 squared, which is 36, minus 36, which is 0. If our answer is 0, we know from the notes that we get 1 real solution, so there is 1 x-intercept. Alright, that will be all for the lesson. Just going to do a quick review. Remember, our quadratic formula is up here. X squared equals negative b plus or minus square root b squared minus 4ac all over 2a. The discriminant is what is underneath the radical in our quadratic equation. So the discriminant is b squared minus 4ac. Okay, and the last thing we want to just quickly go over is if we have the number of solutions or the number of x-intercepts. So let's remember that if our discriminant is a positive value, we get 2 solutions. If our a is positive and our discriminant is positive, our graph is going to look something like this. I'm going to use another color. If our discriminant is 0, we get one solution or one x-intercept. And remember, if our a is positive, we're going up. And if our solution is 0, we get one x-intercept, which looks like that. And last but not least, if we have a negative discriminant, we have 0 x-intercepts, 0 solutions. So our graph, if our a is positive, is going to look something like this. And that will conclude this lesson.